Here we have a job that pays a salary of $30,000 the first year, and during the next 29 years the salary increases by 6% each year. Well, another way to say that is that to get from the salary of one year to the salary the next year, we would have to multiply that by 1.06. And the reason for the 1 there is that from one year to the next, the salary is 106% of what it was the year before, because we start with 100% of what the salary was the year before and add 6% to that. So 106% as a decimal would be 1.06. So if we were to list out all of these salaries in the first year and then in the second year and the third year and so on, that would generate a sequence, and to get from one term to the next in that sequence, we would be multiplying by 1.06. So that means that we would be looking at a geometric sequence with a common ratio of 1.06. Now our question is, what is the total lifetime salary over the 30-year period? So we would want to add up all of the salaries in each of those 30 years. And since we have identified this as a geometric sequence, fortunately we have a formula for the sum of the first n terms of a geometric sequence. And that is Sn equals A1 times 1 minus r to the n over 1 minus r. So we have already identified that r is 1.06. Now the only other thing that we need in our formula here is A1, and A1 just means the first term, which would be the salary in the first year, which it says is $30,000. And then the sum that we're looking for is the sum of the first 30 terms, because we want this total over this 30-year period. So we're looking for S30. So the n is 30. So plugging everything in, we get 30,000 times 1 minus 1.06 to the 30th power over 1 minus 1.06. Now it's asking for us to round our answer to the nearest dollar, but we don't want to round until the very end. As if I start doing operations like, say, this 1.06 to the 30th, and I round that, and then I have to do 1 minus that, and then 30,000 times that, and then divide it by something else, I might introduce some rounding error, and my final answer may not be as close as I need it to be. It may not be accurate to the nearest dollar. And so to avoid any kind of rounding error, really our best idea is to just input this entire expression into a calculator and let the calculator evaluate that and then round that answer that we see to the nearest dollar. If you have to do it one step at a time, use as many digits as you can. So if you do 1.06 to the 30th in your calculator, write that out to as many digits as your calculator shows, so that when you do the other operations with it, you have the least chance of getting some rounding error. So punching this all in a calculator at one time, we get a value of 2,371,745.5864 and so on. So rounding to the nearest dollar, the next digit after that's a 5, so that would have to get bumped up to a 6 there. So we'd have 2,371,746 as our answer rounded to the nearest dollar.